welcome. We're going to do a quick video here on some notes for doing some measurements with coordinate geometry or measurements of things on a grid. In particularly, we're looking at distance measurements. So first, let's start out with just the basic idea of calculating distance in a very simple way. It's just calculating from how far you've gone from where you start to where you finish. So when I look at this first example, we just have vertical and horizontal lines. The horizontal line goes from -2 to 4. And if I were to think about this exact coordinate, it's at -2, 2 to 4, 2. Because the height is 2 the whole time, that's not changing. All I need to calculate then is the horizontal distance. And I go 2 and then 4 more. And if I were to kind of calculate that, I could say that's like 4 minus -2. And that's the same as 6. Another way that I could have written that is just 2 plus 4, thinking about how far am I on the left side and how far am I on the right side. And that's also going to equal 6. So no matter how I say it, both of those ways give me the same thing. I'm going to go ahead and take a snapshot of that for my work in the equations. Let's make sure it's going to my clipboard. Good. And we'll put that in here. We're going to do some more equations as well for the vertical one. In fact, you know what? I'll wait until I do the vertical one, and then we can get that. So the vertical one here goes from -2 on the y-axis down to -6 here. And if I'm trying to figure out how far that is, from 2 to 4 to 6, that's 4 units long. There's a couple ways I can do that. So one of them is I could say the further number, or -2 minus -6. And that's going to give me 4. If I were to have written it the other way around, like let's say I said -6 minus -2. And that's going to give you like a calculation of -4. And you might be saying, so which one is it, 4 or -4? Well, distance, we don't talk about distance in terms of negative. So it would have been just the absolute value or the positive only value of those things. So I'll screenshot all these things, but keep in mind that we're just looking at just the positive numbers. All right, put that in here. Shrink it down just a little bit. Keep it inside that square. All right, now let's get into like the meat of it. When we have a diagonal line, are we going to be using Pythagorean theorem, midpoint, addition to calculate things? We are going to be using Pythagorean theorem. Let's look at this drawing and add some information that makes it a little bit easier. I'm going to start by drawing a triangle with this piece here. And what I can do, I don't want that back piece, just those two pieces. So I can make a triangle like that. If I want to make it a little bit easier and actually draw a triangle, I could say I'm going to draw a triangle that fits that size, and I'll flip it vertically. I could have also just like rotated it kind of thing. Another way that I could have drawn a shape like that is with a polyline. That's probably the quickest, most rough way to do it, but it works just fine. So now I have this triangle here, and what I'm interested in looking at is the edges of the triangle. I see that I have a 3 for this edge and a 4 for that edge, because I go from 0 up to 4, and I go from -2 to 1, and that's a count of 3. I'm going to refresh my calculation over here. Now I know that the Pythagorean theorem is a squared plus b squared equals c squared. I know that, and if I'm trying to figure out what's this diagonal line here, the a and b are my vertical and horizontal lines. So then I would add this with numbers, I'm going to say 3 squared equals, or plus 4 squared equals c squared. Now what you're going to start noticing is that we're doing this Pythagorean theorem a lot. And we just want c, we don't want c squared, because we're trying to figure out what's this calculation of distance. So we're going to wind up square rooting that side and just trying to figure out what's the value of c. Well, 3 squared is 9, 4 squared is 16. Put those together, that's 25. And the square root is going to be 5, but again, we're thinking distance, so we just want the positive number. So we know that that's 3, 4, and 5. Let's put some numbers on my picture here. I can say this is 3. I'll copy and paste that. This side is 4. And we'll paste it again. And this side over here, the diagonal, is 5. All right, so that's 5, that's 3 and 4. I'm going to do the same kind of thing with the polyline tool and create a triangle over on the other side. So I'm going to put a line here, here, on the diagonal. So this one's going to be a little bit different because we have a length of 3 on the vertical, but on my horizontal, I have not 4, but this is 6 units long. It goes from 0 just past 5 to 6. So now I'm going to do the same kind of thing, but instead we're going to have 3 squared plus 6 squared equals that c squared. And you can shortcut this by making all of this inside a square root, and we can go ahead and jump down to that next step. There we go. So 3 squared is 9, 6 squared is 36. I'm going to put those together and get 45. Now the problem is I want, throughout this entire set of notes, exact values. So I got to find another way to write 45 as 2 numbers. So I'm going to try and rewrite 45 as 2 numbers that are multiplied. So that would be the same thing as 9 times 5. Now I'm being very specific in the way that I'm choosing these numbers. I'm choosing 2 numbers where one of them is a square. And in this case, that square happens to be 9. Let's see what that does for me. I can pull these numbers apart, and it makes 2 square roots. And then that square, 9, has a square root of 3. So this right here is going to be my calculation for that diagonal. 3 times the square root of 5, or just the square root of 45. Both of those would be accurate. All right, I'm going to take my screenshot of all this work here. We'll put that into our equations. All right, now for given 2 points, again, we're going to use Pythagorean theorem to calculate the diagonal distance, and we're going to rewrite the terms factoring out squares. And in fact, that should be up here, just like we had before. So I'm going to copy and paste that. But on your paper, your copy, it will all be in there. Let's make some bullet points. There we go. Move these over a little bit. Perfect. All right, so now let's plot some points and find their distances. So I'm going to edit this, and it says that I have a line from -1 to 1. So I'm going to do -1, 1 to 3, 5 for AB. So -1, 1 goes to 3, 5. There we go. And negative 3, negative 2 goes to 1, negative 4. So we have two triangles, both triangles, or not two triangles, we have two segments. I'll make them a little bit more bold here so they stand out. We want to calculate these distances. So again, we're going to use this polyline tool. Let's try that again. The polyline tool, where I just click on the edges, the corners of these triangles that I can use to make Pythagorean theorem. So there's one triangle, and here is another triangle. And these are right triangles. That's why we can use Pythagorean theorem, because we have a horizontal and vertical intersection that makes a 90-degree angle right there. You can't do it with just any triangle. It has to be a right triangle for you to use Pythagorean theorem. This side edge I see is 4. Similarly, the other side is 4 here. And there's also a side edge of 4 down here. And this edge that's left here at the end is 2. So we'll put a 2 there. Awesome. So we got a lot going on. But it's really just Pythagorean theorem calculated again and again. I'm going to go back to, actually here, I'll do this. I'm going to delete this. And for this one, I'm going to go back to this line. Oh, but do we have, no, we don't have. Go back to this line. And I'm going to change this, instead of 3 squared plus 6 squared, it's going to be 4 squared plus 4 squared. And let's see what that does. Well, 4 squared is 16. 4 squared is 16. Add those together, I get 32. Now I need to try and figure out a square that multiplies into 32. And for reference, squares that we have are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. So I'm looking for numbers that are kind of in that list. I noticed that 16 times 2 is 32. So let's do that. I'm going to do 16 times 2. So in this one here, I will change this to say 16 times 2. Instead of the square 9, we're going to use the square 16. Now again, I can pull these apart to make it 2 square roots being multiplied by each other. And the square root of 16 is an actual integer or whole number value, which is 4 root 2. So all of this shows how we can calculate this diagonal edge and write it as an a square root b kind of value. Let's do another one for the other edge. This is square root of 2 squared plus 4 squared. And as I work my way through this, I can square each of those numbers, make it equal to square root of 20. Now I need to figure out what two numbers multiply to 20. Well, square root of 4 times 5 should work. Let's move that a little bit right under it so it looks like it's just continuing on. So I can make the 4 become its own square root, and the square root of 4 is 2. So there's my two values for each of these. For the AB, that's going to be 4 root 2, and for the CD, that's going to be 2 root 5. Let's screenshot this, paste it into our work. There we go. All right, now let's look at some stuff like this. So we're going to do the same things we were doing, but we have multiple terms in which we can combine some stuff. So let's see how that works out. I'm going to refresh this page, start it over. And I'm going to start out with square root of 24 plus square root of 27 plus square root of 54 plus, and then the last one is square root of 12. Now, see, the thing is, none of these are like terms. Like, I can't take one thing and combine it to any others. I can move them in different orders, but I can't really combine any of these numbers right now. But what I can do is find ways to multiply each of these. Now, I'm going to use a tool over here to start showing some of these things. This is also a tool that will be linked into the notes if you'd like to use it. What it allows you to do is I could say something like, I want to start with the number 24. And 24, I want to find a way that I can split that into two numbers that multiply, but multiply in a way that one of them is going to give me a perfect square. And that's close, 16 times 1.5, but it's 1.5, so I don't have that yet. And now we have something. 24 is 4 times 6. So I'm going to change 24 to say, actually, you know what I'll do? I'll rewrite it down here. 24 is going to be 4 times 6. Now let's try 27. So I'll scroll this up to 27. And 27 isn't divisible by 2, but it is divisible by 3. So that becomes 9 times 3. So we'll have square root of 9 times 3 for the 27. And then 54. All right, let's do 54. I'll push this up to 54. That also has a 9 times something. So I have square root of 9 times 6. And I think that will be good for us. And then the last one is a 12. I'm going to pull this tool down to 12 and see if it doesn't multiply by 9. Does it multiply by 4 or a 16? No, but here we go. 4 times 3, where our square is 2 by 2. So we'll have plus 4 times 3 for the 12. All right, so we got a lot going on here. Whoops, didn't mean to do that. I just want to arrange this right underneath it so you can tell that these are equal pieces. Now the 4 times 6, I can pull out the 4. I can pull out the 9. I'm doing the same thing all the way across here. And that means I'm going to have a 2 root 6, a 3 root 3, a 3 root 6, and a 2 root 3. Ooh, now I have some things. Notice that I have square root. So this 3 and this, let's see if I can do that correctly. I don't want to do that. Go back. If I hold down Shift and highlight multiple pieces, I can't combine that here, but I can combine it with this one. Notice that it can go together because the square root of 3's are there, but it can't go with this one. So I'm going to move it over there. I'm going to swap places. And now these 2 square root 3's, that's like saying 3x plus 2x, which makes 5x, or 5 of those put together. Similarly, I'm going to have something over here where the 2 and 3 can combine because these two radicals are equal to each other. So I have all that work to finally come down to these 2 terms there. Capture that and put it into this. It's a lot of work. All right, now I'm going to pause the video and record this last bit because I forgot to include the picture in here, but we're gonna go grab that. Like magic, this problem is now filled in. So let's take a look at what we have. We have a triangle here with 3 edges, and it's asking for the perimeter of the triangle, right? And if I want the perimeter of the triangle, then what I'm looking for is something where I'm calculating all 3 edges, not just one edge, but I got to do that edge calculation 3 times. Well, let's go in and see like the easy stuff that we can calculate. First, this bottom edge, that is a lot easier than you would think. This edge from 0, 0 to 7, 0, that's just 7 units long. So I'm gonna just put a little text box in there saying that's just 7. And we'll make it nice and big, easy to read. So that's 7 for that edge. Now this edge, let's do a polyline tool. I could create a triangle here. And similarly, I could create a triangle on the other side. So let's talk about the left triangle. This left triangle goes from 0 to 3. See, that points at 3, 4. And from 0 to 4 in the other direction. So that means I will have a value of 3 for this horizontal line. And 4 for this vertical line. And because it's a horizontal line and a vertical line, I can use Pythagorean theorem to calculate the diagonal line. Now, the way that we had seen how we can do that calculation with Pythagorean theorem was if we had like a box, something squared plus something squared equals C, that diagonal distance. All right, so let's fill these things in. This box I'll fill in with the 3, and this box will be the 4. Awesome. And then we know that 3 squared is 9, 4 squared is 16. Add those together, and what do you know? 25 is one of those perfect squares. So that edge there is going to be 5. We will copy and paste this text box, and we'll say this edge right here is 5. Cool. Now let's look at this other edge. This other edge has a horizontal from 3 to 7, which that means that side's going to be 4. And then a vertical from 0 to 4, so that side's also 4, so I don't have to edit that number at all. It's 4 and 4. So for that calculation, I'm going to do the same kind of thing. I'm going to copy that, and I think I can just paste it. Can I do that? Oh, maybe not. Well, it's not too hard to rebuild. We're going to have the square root of something squared plus, whoops, pressed enter too fast. Square root, oh, we're doing, let's see if I can try this. Well, let's delete it and try again. We have the square root of something squared plus something squared equals C for that diagonal distance. We can move it over a little bit just so it fits in our picture. All right, now my two distances, my horizontal and vertical distance, are 4 and 4 which means now I can calculate 16 and 16, and that's 32. But now I need to figure out how could I rewrite 32 in a way where it's simplified with a coefficient outside and a number multiplied inside. So I'm going to have to do another square root, and I think it's going to be 16 times 2. And just to confirm, we could do it over here with this tool. So if I go up to 32, and this kind of works, but I think I can go higher. And for sure, I can go higher. You want to go as high as possible and still have a number that comes out with perfect whole numbers. So it's going to be 16 times 2. And I can pull that into 2 square roots, making that outside number a 4 square root 2. Now I can take a screenshot of the work I have so far. Believe it or not, there is still more to do, which sounds crazy, but you're going to see what we mean by that. So I have this much so far. We're going to make it a little bit smaller because we still have one kind of last thing to do. We know that the bottom edge is 7, that edge is 5, and this edge is 4 square root 2. So I got to calculate those three things together. I got to say 7 plus 5 plus 4 times the square root of 2. And I can't combine this 4 with anything. I can't really put it here or there. I can reorder it, but I can combine the 5 and 7. And this is my final answer. Can't simplify it any further. I've done all the combined like terms. I've done all the rewriting the square root into the smallest coefficient and inside piece that I can. And that gives me my final answer. And when you're looking at this on a skill quiz, this is the answer that we're going to be looking for. In fact, it's going to already give you the square root of 2 piece, and you just have to figure out what the other two numbers are. So the square root of 2 gives you a little bit of a clue as to how you're going to rewrite some of the pieces. And that's it. Thank you.